Hi, here we are going to discuss about four queens problem by using the state space tree with backtracking method. The problem is given with the 4 cross 4 chessboard. The rows are indicated with index values I, and here the columns are indicated with index value j. Like that, for queen 2 we are using the rows are indicated with k variable and columns are indicated with l variable for the another queen. And here we have to arrange four number of queens given in the chessboard 4 cross 4. The criteria we have to follow: no two queens attack each other when you are arranging on the chessboard. For getting the solution, you can build the state space tree by using backtracking method. Here the goal state should be like this: queens are arranged here in the rows and column. For that, we are having implicit criteria. When you are arranging the queens in the chessboard, no two queens are placed in the same row. That means when you are placing two queens in the same row, then it will attack each other, right? For if you place one more queen here, this will attack this one. Okay, and also you cannot place two queens in same column, right? Like this, here if you place one more queen here, this queen will attack this queen, right? So we cannot place two queens in the same column. Like that, in same diagonal we cannot place two queens. That means here if you place one more queen in this one, then this will attack. So we should follow this implicit criteria. No two queens can be placed in same row, same column and same diagonal. And the explicit criteria is here we are having four queens: q1, q2, q3 and q4. So the q1 should be placed in the first row, q2 should be placed in the second row. Like that, the ith queen has to be placed in ith row, but you can use any one of the column. You see, the first queen is placed in the first row, but second column is selected. Here second queen is placed in the second row, but fourth column is selected. So you can select any one of the column, but the row should be equivalent to the queen number. Okay, that is the thing. Now we are going to solve that using state space tree. When you are using the state space tree, you will construct like this. Okay, the node is started here. Then for queen 1, which is the column I can select? I can select first column, or I can place in the second column, I can place in the third column, or I can place in the fourth column. So there is four options available for the queen 1. Suppose if you select the path branch 1, then here I'm going to place in the next level queen 2. So when you are placing the queen 2 here, already we have placed the queen 1 in first column, right? Then you cannot select the first column for queen 2. So which is having three options: queen 2 can be placed in the second column, or third column, or fourth column. Now you see, queen 2 you assume that placed in the second column here. Then now we are going for next queen, queen 3. So for that, there is only possibility two options: either third column or fourth column. Like that, if you select this one for the queen 3 third column, right, then here for the queen 4 I have only one option, that is fourth column. So like this we have to arrange the queens. But when you are arranging the queens, we should follow this criteria. In this structure I did not follow the criteria. For example, I have given this one. Suppose if you are placing the queen 1 in the second column like this, by ignoring this path, then I will select for queen 2, right? For queen 2 I have three options like I can place that in first column, I can place that in third column, second column I cannot use because queen 1 is placed in the second column. Then fourth column can be selected for the queen 2. Then if queen 1 is placed in queen 2, queen 2 is placed in 1 and queen 1 is placed in 2. So then for queen 3 I can select except 1 and 2. So 3 is possible. Another option is 4 is possible. Fourth column and third column is possible. If you select the third column for the queen 3, then for queen 4, we are having only one option, right? Fourth column. So like this, we can construct the state space tree for placing the queens. Okay, so when you are constructing like this, what is the total number of nodes in the tree for 4 queens problem? There is formula 1 plus summation of j equal to 0 to n minus 1 of pi, that means product of I equal to 0 to j n minus I. So here you can substitute the values. Here n is 4, 4 minus 1 3, then product of I equal to 0 to j 4 minus I. 4 is here n value, 4 queens problem. Now you see how we are getting this one. Suppose if you are selecting the 4 queens problem, then 1, then here I am selecting initially j equal to 0. If j equal to 0, then here for pi we are starting from I equal to 0 to 0. Okay, j equal to 0. If it is the case, now 4 minus I value is here 0. So 4 minus 0 we are getting 4. Then second time j equal to 1. If j equal to 1, then product of I equal to 0 to j value 1. So now when you are substituting 4 minus I equal to 0, 4 minus 0, then second time I is incremented, I will become 1, so 4 minus 1. So you got 4 cross 3. So that is the value we are getting here. Then when your value j equal to 2, right, when j equal to 2, then product of I equal to 0 to 2. Okay, so then you have to substitute 3 times 4 minus 0, then multiply with 4 minus 1, multiply with 4 minus 2. That means this I value is 0, then 1, then 2. So 3 terms are we are getting. This term 4 minus 0, 4 minus 1 3, 4 minus 2 2. Then when you are increasing the j value to 3, we are getting here the product of I equal to 0 to 3. Then what you will get here, you have to substitute the I value 4 times. First I equal to 0 we are taking. For I equal to 0, 4 minus 0, multiply with, then I is incremented by 1, 4 minus 1, right? uh, then I equal to incremented by 1, so 2, I becomes 2, so 4 minus 2. When you are substituting the values here, multiply with, then I is incremented to 3, then 4 minus 3. So when you are applying that subtraction options, 4 minus 0, 4 minus 1, 4 minus 2, 4 minus here 3. So when you are doing this calculations, you will get 65 number of total nodes for the state space tree given in 4 queens problem. Then how many number of leaf nodes? Leaf nodes will be n factorial, that is 4 factorial equal to 24 number of leaf nodes in the state space tree, right? So until root we will have, so the leaf nodes will be 24. Now here, how do you find the same row position for 2 queens? You see, when you are placing the queens here, suppose this is I comma j, then second queen I am placing here in the second row, same column, okay, or same row. First I am taking the same row, so here I am placing queen 2, for example here. Okay, so k comma l. So in this position you see j is equivalent to l. Okay, so right, for same row. Okay, same row means I equal to k, I equal to k. So when the index value I equal to k, that means row I equal to 1, k equal to 1, same row. So if both are same, we can decide that 2 queens are positioned in same row. Likewise, when you are checking the index of I comma j and k comma l, if j equal to l, suppose I am placing one more queen here, okay, queen 3, you look at that, k comma l, so here k is 3, l is here 1, like that here I equal to 1, j equal to 1, you see j value and l value both are same. If j value and l value are same, then we can conclude that both queens are in same column. Okay, likewise, how do we check the diagonal position? For diagonal position, you see I comma j is placed here, k comma l placed here, I comma j 2 comma 2, okay, then k comma l 3 comma 3. So now you apply the formula here, I is here 2 minus k is here 3, okay, as per this example, then equal to j is here 2, l is here 3, right? So now minus 1 equal to minus 1 inside the mod, then 1 equal to 1. If both are equal, then we can say that queens are placed in diagonal, same diagonal position, so we have to avoid this position. So like that we can identify the same row, same column, same diagonal position. So here another an example is given, we have placed the queen 1 in 1 comma 2 this position, then 2 comma 3 for the queen 2, so this position. So when you are applying this I minus k, right, I minus k, you are getting minus 1, then here j minus l, you are getting minus 1, so both are similar though, so we can say both are available in diagonal position. So like this we can identify the position of each and every queen comparing with another queens. Based upon this, we will see the example in next video. Thanks for watching.